All right, now that we've talked about kind of an introduction to Python, let's go ahead and dive right into assignment 5. So it's due on November 6th, and if you do extensions, be sure to submit a regular and extension version of your program. And yeah, that's it. There we've got 2 problems meant to help you dive right into Python while exercising your programming expertise that you've been working out throughout the whole quarter. The first problem is a random sentence generator, and the second problem is reassemble. We have 2 separate problems. These are not 2 milestones, they're 2 separate problems. Within each problem, we don't have milestones. However, they are mostly kind of pre-decomposed into very nice parts. Throughout this entire assignment, please keep in mind kind of good decomposition. Each problem 1 and problem 2 both have a number of parts to them. And as a result, if you kind of decompose these various parts into different functions and think about how you're going to architect your program before you actually start writing code. That's the single biggest piece of advice I have here. And if you follow it, it'll set you up for success, both with this assignment and in general when you're writing code. So let's talk about part 1, which is the random sentence generator. We're going to use something called a CFG, or a context-free grammar, to generate random sentences that appear to a set of rules, that adhere to a set of rules. Okay, and a CFG is kind of a formal language, which is this notion in computer science, theoretical computer science in particular, in addition to kind of math and linguistics. A CFG defines rules, and we say that a sentence is in the language if it conforms to the CFG's rules. So to the right, we have this basic context-free grammar, or CFG. There are several definitions in the CFG, context-free grammar. Definitions start with a non-terminal. In other words, a symbol that can and should be kind of expanded. Non-terminals are kind of placeholder items for what will be later expanded into their productions. So each of these rules here is also known as a production or an expansion. Each expansion or production contains space-separated tokens, or you can think of these as words, but in reality they're tokens. And the tokens themselves may be terminal, in other words, you don't need to expand them anymore, or non-terminal, in which case you do need to expand them. If a production contains non-terminals, you'll eventually have to expand it. So this expansion right here, or production, you'll have to expand it further because of the non-terminal here called adverb. So for example, these are all the expansions that have non-terminals in them. Immediately after each non-terminal, there's a number, and it says how many rules or productions there are for expansion. Note that the empty string is generally a valid production. You can also assume that the CFGs are correctly formatted, so you don't need to do any kind of error checking. So now let's actually go ahead and generate a sentence manually. So we start always with the start definition right here. There's only one definition for start, so we go ahead and choose this kind of expansion. Okay, and we choose the expansion randomly. In this case, there's only one. And so now what we can do is we have this expansion here, the object verb tonight, and this kind of represents the current sentence that we are building up so far. Does this expansion have any non-terminals? The answer is yes, it has 2. And so let's go ahead and expand them. It's the same thing. So for object, we pick a random expansion or production. Let's say we pick that one. And now we substitute the non-terminal for the production that we picked. So we substitute object here with this rule, this expansion, which is just the word slugs. Now we do the same thing. So we have the token verb, which is a non-terminal, and we're going to go ahead and expand it by picking a random production. Let's say we pick that one. And now we substitute. The slugs portend like object tonight. And now we need to expand object, which is a new non-terminal that just got introduced. We pick a random production, and then we go ahead and substitute that in the sentence. And now we're out of non-terminals. In other words, we are done. So that's the final expansion. The slugs portend like big yellow flowers tonight. And notice that this sentence follows the rules defined by start and subsequently defined by each of the non-terminals in the starting expansion that we happen to choose. Okay, and that's our final answer. Very nice prose. Beautiful. So generates random sentences.py is already decomposed for you. If we take a look, this is the file that you are given. And so you actually need to go ahead and, read the grammar, which is a function you'll have to write, and generate random sentences, which is also a function that you're going to have to write. Let's figure out some data structures that we can use for a grammar. We can start about thinking of these definitions. These are the main building blocks of our grammar. And we need to think about how we can identify a definition and how we can go ahead and look up a definition. With this non-terminal, that's kind of how we identify the definition, okay? And then we notice that each non-terminal uniquely defines a bunch of definitions here, or uniquely defines a definition, okay? And this is kind of a key value situation. And let's actually nail down what this definition is. So taking a look at object, the non-terminal, we notice that there's some information here. Basically, there's a number, the non-terminal itself, which is object, the number, which is 3, and the productions, which are waves, big yellow flowers, and slugs. So what information do we need to know when we're generating sentences? That's a great question for you to think about. We don't actually need the number, because if we're storing 3 kind of expansions or productions, then we know that there must be kind of 3 expansions for objects, so we don't need to store this number explicitly, we'll kind of implicitly store it. So basically we need the non-terminal, which is object, and the productions, which are these 3 things right here. And now the next question is, how are we going to actually represent the productions? And now kind of we're working backwards, right? So it's important to note that we know what the purpose of the data structure is. In other words, we know what the data structure is going to be used for. And so we're starting with the use case for the data structure and then working backwards to figure out what kind of data structure that we're actually going to use. And specifically, we're going to populate the data structure by reading in the grammar file. We're already familiar with the file structure. We have a bunch of definitions, and each definition is 3 pieces of information. And the key is the object, or the non-terminal, the number of productions, and then the productions themselves. Okay, we're working with lines when we read the file. Each line has a different meaning. So you might want to split up the file into different lines, and then you can kind of interpret each line as is appropriate. Okay, there's 2 ways that we can open the file. Or there's one way we can open the file, and there's 2 ways that we can get all the lines, either with for-line and f, and then lines equals f.readLines. So now a good question to think about is which one should we use? And why? Okay, I'll let you answer that on your own. And once you've read everything into the data structure, all that's left to do is implement the random sentence generator as described previously, at which point you are finished. Now let's move on to part 2, which is reassemble. Here you're going to take fragments of a message and then reassemble them into a kind of overarching message. You're going to go ahead and do this by finding the longest overlap between all of the available fragments and merge them together, and then keep doing that until you're done with all the fragments. You also have to read in fragments from a file that's provided. So fragment files look like the above. Here's another example. Again, each fragment is separated kind of by these squiggly line characters, these squiggly brace characters, and the text in each fragment can have any character except for squiggly braces. So you could have new lines within each fragment, and that would be fine. Okay, fragments can span multiple lines, and that's no problem. So since fragments can span multiple lines, it does not make a lot of sense to read in the file line by line. Okay, instead what we can do is open the file like this, and then read all of the text into a single string. Now let's think about reassembling. So this will eventually kind of reassemble into the string all is well that ends well. But let's explore how to first get there. We need to find the longest overlap between 2 fragments. In this case, we've written each fragment on a different line. The different pairings that we have are printed here on the screen. The order actually does not matter of the different pairings that we have. And so now we look at what's the longest overlap between each of these pairings, okay? And the longest overlap for each of the pairings is printed in parentheses, and then the length is also kind of printed as well. So here the longest overlap is length 3, here it's length 6, length 3, and length 5. We notice here that length 6 wins, it's the longest length of the overlap, and so we merge these 2 into one sentence, or into one fragment, like that. And now we have 3 pairings that are printed here on the screen. We again find all of the different, we have three kind of lines on the screen, three fragments on the screen, and we find all the possible pairings. And then we pick the pairings that has the longest overlap, which is this one right here, and we merge them into one fragment. Now we've got kind of one pairing, so by default we're going to choose it. It has an overlap of length 3, and we're going to merge these into one fragment like that. And now we are done. Because we have no more fragments, we only have one fragment, that's the whole thing. You might find yourselves using some functions for lists. If you call list.pop, providing an index, then you're going to remove an element at index I. It will also return to you the element at index I. List.remove, where you give it some element. To clarify, list.pop takes an index, and list.remove takes an element. So with list.remove of an element, we find the first item from the left, the beginning of the list, that matches whatever element you provided, and it returns. It will, remove that element from a list. You might have to use a double for loop, but something that you should think about is how to make sure that you don't consider the same pairing twice. We also strongly recommend that you decompose the functionality of checking overlap between two strings into a helper function, and that will make your job of finding the maximum overlap much, much easier. Okay, so there are some edge cases. So if there's no match, ABC and XYZ, there's no match, and so we just concatenate the two together like that. Order also doesn't matter. You can also write XYZ ABC instead of ABC XYZ. Here, if we have multiple best options, notice here that we have two map pairings that have length 1. We can go ahead and just pick one of them arbitrarily. We chose this one here. Okay, and so now another example, or here we have two matches, two fragments, and so there's one pairing, and so we merge them, and we're done. In terms of strategy, it's better if you work with the smaller fragment files first, because the big ones can take a long time, and it's harder to verify that you did them incorrectly in the first place. You want to do the file reading first and make sure that that's completely correct, test it thoroughly before you move on to reassembly. Okay? And then if you want to make your program run a bit faster, one thing to do is to make sure that you're not checking the same two strings twice. In other words, don't check ABC CDE followed by CDE and ABC. You're just going to be doing duplicated work. So you might want to think of a way to get around that issue. And now that pretty much wraps it up.